Hey guys, it's Mr. Ray here with our next lesson in trigonometry, grade 10 academic math. So this will be the last lesson in in this unit. So we will have an assignment um, on Friday that will be due on the usual time, Sunday at midnight. And I'm going to give probably 3 or 4 lessons left in the course. So rather than try to jam that into 1 week, I'll do 2 lessons next week and 2 the following week, and that'll be it. Okay, so there'll be another, after this week, there'll still be another 2 assignments, and then I'll be able to work on your marks, and hopefully everyone is happy with their mark. So make sure you finish up any assignments you haven't already finished. Obviously, that would affect your mark if you're not handing stuff in. Okay, so this last lesson is called the cosine law. If you remember the previous lesson, it was the sine law. So the sine law was a formula we used, an equation we used when we had a non-right triangle, no 90-degree angle, or at least we don't know for certain there's a 90-degree angle. So I won't restate the formula here, but in order to use the sine law, you had to know certain information. Okay, so you had to know, for example, in this triangle here, ABC, you had to know an angle and its opposite side. Didn't matter which one. And in addition to that pair of information, you had to know one other piece of information, one of the other 2 angles or one of the other 2 sides, and you could use sine law. Okay, so what do you do if you don't have that enough information? Well, that's where the cosine law comes in. So if you don't have enough sides or angles to use sine law, you can usually use the cosine law. So there's going to be 2 cases where you can use it. So I just want to kind of summarize up here. There's 2 types of triangles that you could be asked to find an unknown side or angle. You could have a right triangle with 90-degree or a non-right triangle. Okay, so I just want to make sure everyone's using the right tools for the right triangle, and that's always going to be the first question you ask, or ask yourself when you get a triangle and you're asked to find a missing side or angle. First thing you always find out, is this a right triangle or not? Because depending on which one it is, you're going to look at some different tools. So if it's a right triangle, well, this is where the trig ratios came in, sine, cos, and tan. So those were very helpful in finding missing sides and angles. We also could use the Pythagorean theorem to find, if you knew 2 sides, to get the third side. And of course, you can always use the 180-degree rule. If you know 2 angles in the triangle, the third angle is 180 minus those 2 angles. Okay, so that's a right triangle. What if it's non-right? Well, you can still use this 180 rule. That doesn't depend on whether it's a right triangle or not. So if you've got two angles, the first thing you should do is calculate that third angle based on 180 minus the sum of the other 2 angles. Okay, now that's not usually going to help you find a missing side or angle that they're looking for. So the first thing you try to use is the sine law. And again, you have to know an angle and its opposite side and one other piece of information. Okay, and if you don't have that, then you're going to use the cosine law. Okay, so here's the formula for the cosine law. But before we get into that, I just want to talk about what are the 2 cases that you use for the cosine law. Okay, and we use these 3-letter acronyms to define them. They make total sense. SSS, that means side, side, side. So if you knew all 3 sides of the triangle, you can use cosine law. Okay, so side, side, side. Now, if you happen to know side, 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 and one other angle, well, then you could use the sine the sine law because that would give you enough information. But this by itself, with no angles, is not enough to use the sine law. So, but you can use the cosine law. The second case is called SAS, which stands for side, angle, side. Now, it's not just, this is in a specific order. So if you knew, so here's your triangle here. If you knew this side and this side length, and you knew the angle in between them. So that's the side, angle, side kind of goes around the triangle. So there's the side, there's the angle, there's the side. If you have this situation, you can tell that this isn't enough for the sine law because you don't have, an angle on its opposite side anywhere. But it is enough to use the cosine law. So these are the two cases. Okay. Now the formula is based on this lettering convention. So we're going to use ABC for our triangle corners or vertices or angles, and little a, little b, little c for the opposite side. So I don't really need you to memorize or even remember the other two, but it's basically if you kind of just look, if I cover this up, hopefully that reminds you of the Pythagorean theorem. A squared equals b squared plus c squared. That is the Pythagorean theorem with the letters mixed around. But that only works for right triangles. Obviously, this is not a right triangle. So you can almost consider this last product here, this thing we're subtracting. This is kind of like the correction factor because it's not a right triangle. Okay, so you can see here there's a lot of places to put numbers in. Okay, we've got your A, B, C, B, C. Those are all the three sides, right? Angle A would be the angle that you either know or you're trying to find. Okay. Now you could come up with other versions of this because you notice this first formula does not have angle B anywhere. It's got all three sides and it's got angle A, but you could rearrange the letters like I've done in these two equations. I've just rearranged them. So if you wanted to find angle B, you just switch the A and the B positions around, and that becomes angle B. And if you want to find C, you just switch around A and C from the first equation. Okay. So that's the equation, and we're going to use that. You can tell by it's a little more complicated or complex than the sine law. So that's why if you can use the sine law, you should use the sine law. Okay. There will be some situations where both sine law and cosine law would work, but it's always better to use the sine law first because it's quicker and it's less work, less chance of making a mistake. Okay. All right, so we've already talked about this. Here's, so that these formulas here will help you find any side or any angle. Okay. Now, if you're trying to find the side, you're going to use, if you want to find side A, you're going to use this version. If you want to find side B, it's that version. Side C, it's that version. If you want to find an angle, well, the formula's not really great for that because the A is really embedded into this right side. So there is a formula where you just basically rearrange the equation and you come up with this. So if I was to take this a step farther, because to get angle B from cos B, you would take the cosine inverse of both sides. So in this case, angle B is equal to cosine inverse. And what I can do is there's a lot of negative signs here. If I multiply the top and the bottom by -1, I can turn this into something that looks a little more positive. Okay, because it's when I multiply the bottom by -1, I get that. When I multiply the top by -1, all these signs switch, and this becomes the formula. Now, a lot of teachers and students will use this when you go into grade 11 and 12. Um, when I solve for an angle, I don't like memorizing anything more than I need to, and I find a lot of students will try to memorize this and make a mistake. But if you know the original formula here, you can always get the angle, and I'll show you that in one of the examples. Okay. Now there's going to be some questions. I think there's one in here where you're given a triangle and you're asked to solve it. Okay, so solving a triangle means find all the missing sides and angles, and in most cases you'll be given 3 pieces of information. Um, for example, 2 sides and an angle, or 2 angles and a side. Um, so what solving a triangle means, you have to find the measurements that you don't know. So if you ever asked to solve a triangle and use the cosine law first, which happens a lot, okay, please be aware that once you've used cosine law once for a triangle, you never need to use it again, because by getting that extra piece of information by using cosine law, then the next thing you find, you could use the sine law. So I mean, you could use cosine law 3 times to find all 3 pieces, but it's a ton of work. So use the most appropriate tool. If you're making a toothpick, use a jackknife, or use a knife. Don't use a chainsaw, right? So the cosine law is like a chainsaw. Don't use it unless you have to. Okay, and that's what this says. Once you've found one angle, you can apply the sine law to find a second angle. Okay, so don't use cosine law more than once. And there's more than one way of solving these things sometimes. So if you're thinking, well, I would have done it differently, well, there's a pretty good chance it would work. My way of doing it, the order I do it, might be slightly different, but the answers should be the same. Okay, so I've got 4 questions here. Obviously, they're all going to use the cosine law. So they're all word problems. Okay, so here we've got the picture and an explanation. So a boat is sailing north through a narrow strait. So a strait is like water between 2 things. So it's between the lighthouse and the rock there. Through one particular narrow section, a lighthouse marks the western shoreline, while a buoy indicates a rock hazard directly east of the lighthouse as shown. Okay, so what is the width of this section? So how wide is that to the nearest tenth of a kilometer? So we do know we've got this side length, basically from the sailboat to the lighthouse. We know it's 4.2 kilometers. From the sailboat to the rock or to the buoy, it's 4.5 kilometers. And the angle between them, those 2 things from the sailboat, is 26 degrees. Okay, so you can see right away, well, for one thing, the first thing you ask yourself, is this a right triangle? And the way this is drawn, it looks like, well, maybe this could be 90. If you don't know for sure, you can't assume that it is. Okay, so even if it looks really, really close to 90, you can't guess that it is. Okay, so this is a non-right triangle. We know this side, and this angle. So the first question you would ask would be, can I use the sine law here? And the sine law, you have to know an angle and its opposite side. So we don't know that pair. We don't know this pair because I'm missing that angle and I'm missing this angle. So we can't use sine law, but we can use cosine law because it's the side angle side situation. Okay, so we're going to use sine law for this. I'm going to label these corners. So L for lighthouse, R for rock, and S for sailboat. Okay, now what I usually do, at least when you're getting started with this, is write out the cosine law as it's given, right? So a squared equals b squared plus c squared minus 2bc cosine c. sorry, cosine A. Okay, now these have nothing to do with ABC, so we have to basically switch ABC for L, R, and S. So this is the way we're going to do it. So in this case, we know two sides, we know one angle. We have to be able to put this in the equation, obviously. So that S there is going to replace the angle A. So it's cosine S. And since that A got replaced with the capital S for the angle, this little a gets replaced with the little s. So basically that side over there. And then the other two sides, well, the other two sides are L and R. This is little r, and this is little l. Okay, so it doesn't really matter what order I put those. I'll put it as, I don't know, L squared plus R squared minus 2LR. Okay, so I basically, all I've really done in this first step is convert the generic formula for cosine law into the one that's specific for this question that we want to use. Okay, I want to make sure everyone understands I can't make this equation with angle L or angle R because I'm not going to be able to do anything with it because I have to know at least three of these four things. So since I know the angle S is 26 degrees, I'm going to use S here, which means I use S here. So now I can start putting things in. I'm going to keep calling that S, little s. Okay, but we can change L to 4.5 squared. We can change R to 4.2 squared, and then minus 2LR, so L is 4.5, R is 4.2, and then angle S was 26, so it's cosine 26 degrees. Okay, so you can see this is a bit of a clunky formula in terms of length and number of calculations and things that can go wrong. So you have to be extra careful when you're calculating this. Now, when I'm solving for this, it's a lot better than if I'm solving for something over here. So what I'm going to do is I'm going to take my time. I'm going to do each of these separately. So 4.5 squared is 20.25. 4.2 squared is 17.64. And I'm not rounding. That's exactly the right number. And then when I multiply these three things, I'm not going to do everything at once. That's a lot to do. So I'm just going to multiply these three things, and I'm going to get 37.8 cosine 26. Okay, and now what I'm going to do two things here. I'm going to actually combine those two together. That's 37.89. And when I do this on the calculator, we'll just practice this one just so you remember what to do. Okay, so for the iPhone calculator, I'm going to first put the 26 in, and then I'm going to do cosine, so make sure it's not cos inverse, it's cos. Make sure it's on degrees, and then press cosine. So that value is cosine 26, and then I'm going to multiply it by times 2, and then times, oops, that's not what it was. So cosine 26, let's start again, and then we multiply by 37.8. Okay, and we get that long decimal. So in this case, since these other numbers were basically to two decimal places, I'm going to round that to hundredths. So that's going to be 33.97. And it's subtracting because it's subtracting there. Okay, and now we just do the subtraction. And I'm going to do the square root at the same time. So when I subtract it, I get 3.92. And when I take the square root of both sides, I get s is equal to the square root. Actually, I could do it this way. When I take that square root and round it to the nearest tenth, s is equal to 2.0. And that's going to be kilometers because these other distances are kilometers. And then answer with a word answer, of course. Therefore, And you can read back the original question. How wide is the section of the straight to the nearest tenth? Therefore, the straight is 2.0 kilometers between the lighthouse and the rock. Okay, so you can see it's a lot of computation using the cosine law. So, you know, we only use cosine law when we absolutely have to. Okay, so there's our first experience with cosine law. Let's try another question. This time we don't actually have the triangle, but we've got lots of measurements given to us. We have triangle DEF. Okay, so I'm just going to draw a fairly generic triangle here and label it DEF. Now, it's pretty hard to draw this triangle by looking at this information. Okay, the one thing that I would use is make sure that this angle here is close to 64, which it might be. It's definitely not unrealistic. So so we know angle E is 64. We know side D, so D is across here. So D is 4.9 centimeters. And we also know that F is 6.2 centimeters. Okay, and that's all we know. Now here's where I was talking about earlier, where it says solve. So we have to actually get three things. We have to get, okay, we've got these two sides, so we have to get side E. We have to get these two angles here, angle D and angle F. Okay, now we're not going to have a real choice as to what we get first, because when I look at this, I can't use sine law because I don't know a pair of angles inside, but I can use cosine law just like above. I've got side angle side. So once you've done this a couple of times, you realize when I do cosine law for this information, I'm gonna get this side. Okay, that's the first thing I'm gonna get, and then I'm gonna go from there. So it's important for a question like this. It's going to involve three steps, one for each of these measurements. So rather than have a real messy answer, you guys need to get organized. So show me and show yourself what you're actually calculating each step. So the first step, we're going to calculate DF, which is really little e. So this is the first thing we're going to get. And again, I'll write out the generic cosine law. Okay, and then I'm going to change it to DEs and Fs. Okay, so again, that's the angle we need in the equation. So we need angle E here. So that's an E, which makes this a little e. And then the other letters are DF. Doesn't matter what order they are. D squared plus F squared minus 2DF. Okay, and so that's the best way to convert the generic cosine law into the one for this triangle. Okay, now we can plug in the stuff we know. So E is what we're looking for, so that stays as E. D is 4.9 squared plus F squared, that's 6.2 squared, minus 2 times 4.9 times 6.2 times cosine 64. Okay, so I'm going to do this a little bit quicker. I'm going to calculate this, and this in this next step. So 4.9 squared, that's 24.01, plus 6.2 squared, that's 38.44. And when I calculate this, remember, on the iPhone, I'd have to get this, then multiply by that, then multiply by that, then multiply by that, and subtract it. So that's minus 26.64. So when I add these two and subtract that, I get 35.81. Okay, and obviously I want e, not e squared, so I take the square root of both sides, and I get e is equal to. Now, um, this is important. Um, so it doesn't say about the rounding, but you can look at the question. The question gives these two sides to the nearest tenth of a centimeter. Well, it actually tells you here. But even if they didn't, you'd see what was given. So we want to the nearest tenth. So the square root of that rounds to 6.0 centimeters. And even though that's a 0, you still put the 6.0 because that tells you it's rounded to the nearest tenth. Putting it as 6 is not quite the same because it doesn't show that it's, as accurate as this is. Okay, so there's our first answer. And to make this complete, I'm going to go back up to the diagram and add in that piece of information we just got. Okay, so I've got that done. Now the D and the F, so when I look at this triangle now that I've added this, this side, I do have a complete ratio. And now I can use sine law using this as my complete ratio. And then I could either get angle D or angle F at this point. Okay, so this is where it's kind of a personal choice. So I'm going to find angle D first. It's totally arbitrary, like I said. So since I'm finding an angle, if you remember the sine law, that means I'm going to put the sine on the top of the ratio. So sine D over little d. So I'm going to plug this right in since we hopefully remember how to use sine law. So little d was 4.9. Okay. And I'm not going to put all three ratios. I'm going to, since this is the one I'm trying to get, the other ratio has to be the one that's complete, which is this ratio here. So angle E and little e side. So this will be sine of 64 on the top divided by 6.0, which is what I just got. So now this allows me to use the sine law here. If I multiply both sides by 4.9, I get 4.9 sine 64 over 6.0. And then if I take the sine inverse of both sides, I think I mentioned a few times, it's always best to do your rounding, do your calculation at the end for especially the sine law. So you basically figure what that is, then you take the sine inverse, you press equals if you have to, and then you round. Okay, I don't want people rounding here, 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 because then the answer gets a little bit off. So when I do that in the calculator, I get rounds to 47 degrees. There's my second piece of information from the triangle. So I've got that. I go back up here. Angle D is 47. Okay, now the last piece is this angle F. Now hopefully you're not, I don't want you just blindly thinking you've got to use sine law, cosine law all the time, because at this point we know two of the three angles. Okay, and remember on the first page I talked about the tools you can use for a non-right triangle. There's sine law, cosine law, and the 180 rule. So that's what we're going to do here. We're going to find angle F. So the angle F is going to be equal to 180 minus 47 minus 64, and that works out to 69 degrees. There's my third piece. I did 3 steps, one for each of these pieces. I go back up here. I add that to my diagram, 69 degrees. I now have solved this triangle. Started off with just 3 pieces of information, and now I know all 3 sides, all 3 angles. Okay, so that's definitely a question that you'll see on the assignment this week. Make sure you're knowing all the tools based on the type of triangle and how you solve a triangle. Okay, so 2 more examples. We've got these 3 towns here. Three towns are connected by two roads as shown. So Brookside to Rolling Meadows to High Cliff. We've got the measurements there. A third road is planned that will directly connect Brookside and High Cliff, which are 16.5 kilometers apart. So they actually didn't put this in the diagram. I'm not sure why, because it's asking you to read the question. So we actually know all three sides. Do we know any angles? No, we don't. Okay. Find the angle to the nearest tenth of a degree between the new road and the existing road. So here's the new road. So we want to know this angle here, and we want to know this angle here. So it's not quite completing or solving the triangle, because they didn't really ask for this angle, but they're asking for these two. So there'll be two steps here, but it wouldn't take much to get the third angle once you know these two. Okay. All right, so find the angle to the nearest tenth of a degree, okay, between the new road and Rolling Meadows, and the new road and Brookside, I think. Sorry, Rolling Meadows to High Cliff and Rolling Meadows to, yeah. Okay, so, and again, it doesn't matter which one you do. So let's put some letters here. I mean, it's pretty obvious. We're going to pick a B for there, going to pick an R for there, and an H for High Cliff, just to keep it close to the actual name. Takes away some of the monotonous of just picking ABC all the time. Okay, so that makes, that makes this little R, this will be little h, and this will be little b. Okay, you don't have to put those on, but just so you remember. Okay, now if I'm asked to find stuff here, obviously since I don't have any angles at all, that I can't use the sine law. But since I know all three sides, I can use the cosine law. Okay, so my first step, I'm just going to make a decision that I want angle B first. Because really, you could get either angle as your first. So find angle B. Okay. So since I'm finding angle B, well, let's do the same thing we did before. So the generic version of cosine law looks like this. Now don't confuse this B with the B in here. This is just generic. So since I'm finding angle B, I need to have this as the B. Okay. So my actual equation, I'm going to have angle B there, and I'm going to have side B here. And then the other two sides, A and C, it doesn't really matter where they go. And probably going to run out of room here. So now you plug in the side length. So B is 15. A is, oh sorry, that shouldn't be A, that should be, not sure why I didn't change those. So instead of A and C, it's going to be R and H. So R squared and H squared minus 2RH. Sorry about that. Okay, so R, that's 16.5 plus H squared. H is 10 minus 2 times 16.5 times 10 times cosine B. Now you notice when we do the cosine law this time, the other times we've used it, that was the unknown, so we just figured out what's over here, took the square root, and we solved for it. This is going to be a little trickier, because we actually have to figure out what B is. This is where, I talked about at the beginning, there is a formula you could use to get that by itself, but, I prefer to not do that, just because of the mistakes that can happen. Okay, so once I square these numbers, get 225, this is 272.25, this is 100. When I multiply these three things, I get minus 330 cosine B. Okay, now this is the most common mistake in grade 10 math. Okay, I can definitely add these two numbers together, and then I can subtract them from both sides. What I can't do, I can't add these and then subtract 330. and I hope everyone sees why. It's because of bed mass. This 330 is multiplying with cosine B, so I can't subtract it and then multiply everything with cosine B. It's only the 330 that's multiplying. So it almost is it's a good idea to put brackets around there to stop you thinking, oh, I'm going to subtract 330. Okay, so when I can still combine these two, 372.25 minus 330 cosine B. Okay, so what I can do, I can subtract 372.25 from both sides. I think this question's in your textbook too, so if you want to follow along there. My writing might be a little difficult to read on this question. So we get it down to here. Negative 147.25 is equal to negative 330 times cosine B. So do I add 330 to both sides? No, I divide both sides by negative 330. So basically, if I divide that, I get 147.25 divided by 330. And because it's a negative over a negative, I can cancel both of those out. And that's equal to cosine B. And then if I take the cosine inverse of both sides, angle B is equal to cos inverse of 147.25 over 330. Okay, and when you do that, you get it's equal to 63 degrees. Now, I think it said to the 10th of a degree, so I've already done the calculation here. Normally we don't do angles to tenths of degrees, so I'm going to kind of ignore that. So I'm just going to do it to the nearest degree. So 63 degrees is angle B. So I could go back up here and put 63 there. Okay, so that gives me angle B. Now the second part is to get angle C, angle H. Find angle H. Okay, now at this point, and it's important to put the information you just got in this step one, because now you can see I know this side and its opposite angle. I know both of these, and I know quite a bit, I know the other two sides, so I can definitely use sine law now. So don't make the mistake of thinking you should be doing cosine law, because you don't have to after you've got this piece of information. So I'm going to use sine law for H, so that means it's going to be sine H over little h, which is 10. And now I use the complete ratio, so this one here. So it's going to be sine 63 over little b, which is 15. And I get sine h, multiply both sides by 10. And then angle h is equal to sine inverse 10 sine 63 over 15. And when I do that, I get angle h is 36 degrees. Okay, so I go back up here. This is now 36. You could put your answer in words here, but I think by putting these measurements back in the triangle, you're sort of answering it. So I wouldn't be upset if you didn't put a word answer here, because you're basically reflecting that, but of course, it's always nice to put a word answer. Therefore, the angles from the new road to the existing roads are 63 degrees and 36 degrees. Okay, so that you can see how much more difficult it is to use cosine law to find an unknown angle. It's quite a bit more work. Okay, so do I really want to do that twice? Of course not. So I don't have to in the second step to find this angle, because I now have enough information to use sine law. You can see how much quicker it is to get that second angle, okay? And if they ask for the third angle, would I use cosine law? No. Would I use sine law? Nope. I would use the 180 rule, because once I got these two angles, the third one is basically 180, subtract them. Okay, one last question here. So we've got, so no picture this time. We have to draw our own. Runners in a 10K race follow a triangular course. 3 legs of the race in order are 3.8, 2.4, and 3.8 kilometers. Find the 3 angles for each pair of legs in the course. So hopefully when you look at this, you go, oh, look, 2 sides are the same. Okay, so that's an isosceles triangle. So I've got this side is 2.4 kilometers. This is 3.8, and so is this. So they want to know the 3 angles inside this course. And you can see, well, these 2 sides are the same. And you can save yourself some steps here, because hopefully you remember isosceles triangle. Not only are these 2 sides the same, but these 2 angles are the same. Okay, so I'm going to call this AB. Not sure why I called it this. ABS. Oh, that's the start. Yeah. So you know, once you get angle A, well, that's the same, going to be the same as angle B. And once you've got both of these, it's easy to get that one, right? So the only work I really have to do here is to get one of these 2. That gives me the other one as well. And then I just use the 180 rule to get S. So this isn't as tough as a non-isosceles triangle question. So let's find, now what do we know here? We know all 3 sides, okay? Now the way I did this before, I wanted to solve for S first, okay? So step 1, find angle S. Okay, so this time I'm not going to put the generic cosine law. And you can see I'm going to use cosine law because it's side, side, side. There's no way I could use sine law here. So if I'm looking for this side here, that means this side here, which is S, that will be the beginning of the formula. So it's going to be 2.4 squared is equal to, and then it's these ones squared, 3.8 squared plus 3.8 squared minus 2 times, and then both these sides again, 3.8 times 3.8 times cosine of angle S. Okay, so hopefully you can see where that comes from. It all starts from, I want to get that angle. The cosine law only has one angle in it. So if I'm looking for that angle, that's got to be that letter over there, which makes this the opposite side, and these 2 are the other 2 sides. Okay, so when I put these numbers in, square them, 5.76, 14.44, notice these are the same. Now this is also, if you notice this, that's 3.8 squared as well, but 2 times it. So that's actually minus 28.88 cosine S. Okay, now this is where mistakes are made. Okay, you might look at this and go, oh, look at that, 14.44 plus this, that's 28.88 minus 28.8, that would be 0. No, you can't do that because these 2 things are glued together, they're multiplying. BEDMAS, you can't subtract this first, okay? But I can add these 2 together, 28.88, which is what I'll do, minus 28.88 cosine S. Okay, now I can subtract this. So when I subtract 28.88 from this, I get negative 23.12 is equal to negative 28.88 cosine C. Why do I keep saying C? It's S. Okay, and now these 2 are multiplied. To get rid of this, I divide both sides by 28.88, negative 28.88, but because these are both negative, I'm going to cancel them before I even write them. That's equal to cosine S. Therefore, angle S is equal to cos inverse of 23.12 over 28.88, and that is equal to 36.8. What did it ask for rounding here? Well, I'm going to leave it to the nearest tenth. I think I did that because of the next part. So there's the first angle. So this is 36.8. Okay, then second and third step together, we're going to find A and B at the same time because they are the same. So angle A is equal to angle B, which is equal to, I start with the 180, I subtract the 36.8, and then I divide by 2 because what's left over from this is for both A and B together, and A and B are the same. So we do it that way, and we get 71.6 degrees. I think the reason I went to the nearest tenth is because if that was 37, then this would have to be a decimal, and if I rounded the decimal, they wouldn't actually add up to 180. So unfortunately, that was just the way it worked out. So we should, this question, one of the few questions where it would make sense to round to the nearest tenth, just so everything adds up correctly. Okay, so there's your three angles. Therefore, the angles around the course are 71.6, 71.6, and 36.8 degrees. Okay, so hopefully that makes sense to you. You can see these questions can take a bit of time, but you know, as long as your algebra skills are pretty good and you know how to solve, especially when you're solving the angle for cosine law, as long as you're careful, everyone makes some mistakes. Don't worry about it, but just take your time. Don't try to do too much in one step. Make sure your rounding is correct, and everything should work out. Okay, so there's some questions here. This is actually from two sections of the textbook, so these are more. First part is just more, here's a triangle, what's this angle, what's this side, and these are more word problems from what I understand, from what I remember. So try a few of these. The homework solutions will be posted so you can check your work, and then there'll be an assignment on Friday for mostly sine law and cosine law, okay? But you'll still have to remember a little bit from before. Okay, all right guys, have a great night. We'll talk to you soon.